Exercise 6E and 6F, we're going to spend 2 sessions on this, and we're going to start off with the turning point form for a cubic. Okay, so whatever you learnt in quadratics, you can apply it directly to 6E for cubics. So, your cubic graph could look like this. That cubic graph, the reason why you know it's cubic is because it has 3 x-intercepts. Okay, because it has 3 x-intercepts. It could be an x cubed graph. So this graph here has x-intercepts at -3. It has x-intercepts at -1. It has x-intercepts at 2. So if you were to write the linear factors, it would be x plus 3. This would be an x plus 1. And that's an x minus 2 to get those answers. Okay, so these are your linear factors. And the only thing you don't know is A. So this is very similar to what you did with quadratics, where I told you read the number of x-intercepts you have. If they give you 3, you can write out your 3 possible x-intercepts, and the only difference is you got to solve for A. Now the only way to find A is if you get a point, which, yeah, you can sub that in and you can find out A, and that is the equation for that particular cubic graph. So it's very similar to what you did in quadratics. That's why I'm saying if you understood quadratics, it helps cubics. Yeah? But anyways, for today's session, we're not going to move into this yet, but I was just giving you a quick idea of what you're doing. What I want you to see is what you'll need is to be able to read the turning point form for a cubic. Now this turning point form is exactly the same reading as you would for a quadratic, in the sense that anything that you add tells you up or down. Yeah, so plus is up, minus is down. If you want to find if it moves left or right, what do you have to do again? Make it equal to 0. So if you let x plus b equal to 0, so what's inside the brackets equal to 0, solve for b. If x is negative, it goes left. If x is positive, it goes to the right. Okay, and then finally a, what does a do to the graph again? Yes, Trainer. Yeah, it makes it thinner or wider. Okay, so it makes it thinner or wider. And one more thing. What else does it do? Yes, it's a smiley face or frown face. Now, in this case, it's not going to be like a smiley face or frown, but it's pretty much inverted or upright. Now, for a cubic graph, what I want you to see is the cubic graph has this sort of shape, in the sense that it goes further down if you keep going in the negative direction. If you keep going further negative, the graph goes down. If you keep going further right, it keeps going up. Now, if I asked you to sketch on your calculator an x cubed graph, okay, that's your most basic cubic graph. So anything cubed, just like you have anything squared, you have anything cubed. Then this graph looks like this. Okay? So it's very similar to your quadratic in the sense that quadratic is symmetrical, then cubic is asymmetrical.
If I found 2 points on the graph, would they be, if I found like the opposite, just with the different signs?
Yeah, you're right, because let's say 2 cubed, what's 2 cubed equal to? 8. So at 2, you got positive 8, but then at -2, what do you have? What's -2 cubed? -8. So you're right, it is the same value, except it's in the opposite direction. That's why it's asymmetrical. So this shape here is positive. It's sort of like it's reflected and reflected. If you think about it, I've sort of flipped it along the x-axis and then I flip it on the y-axis and you get this shape. So this shape and this shape are the same values, they're just different directions. Okay? So that is the difference between the two, and that's why it's got that sort of symmetrical look only for an x cube. And all we're going to do in exercise 6E is we're going to analyze this. So we know the shape looks like this, okay? And we know that A will make it thinner or wider. We know that to know if we want to move the center, which right now is 0, 0, the center we call it the point of inflection, if that helps you remember it. It's sort of like flex, and I guess that kind of looks like the arm flexing there. So right at the point of inflection, so I'm going to write here point of inflection, okay, that's where you're moving the center. So when you say move left, right, up, down, we don't really have a turning point at this point. We've got an inflection point, and that's what you're moving. Okay, so that's what we're really just doing today, okay, for 6E. And then next session, hopefully you can put it all together, factorizing, cubic division, factor theorem, find X-intercept, and then find Y-intercept, and you can sketch. Okay, but for now, I'm going to go to GeoGebra so that you can see what I'm teaching you where I say up, down, left, right, and how that affects your cubic graph. Okay, so let's have a look. Where's my GeoGebra? Okay, so here we go. I'm going to zoom in so you can see. Okay, so this graph here is your cubic graph. And that's, I should take that away and make that 0. 0. There you go. So the point of inflection right now is at 0, 0. It goes up, it goes down. Yeah? What I told you is this is just y equals to x cubed. I told you if you want to move the graph up and down, it's what you're adding to the graph and what you're subtracting from the graph. So if I said, let's change c to plus 4, let's just make it 4, okay? So when it's x cubed plus 4, you see I've just moved the center up by 4. So the inflection point now is at 0, 4. So this is still exactly the same as what you did with your quadratics, except the quadratics was like this parabolic shape, and you move the turning point. Now you're moving the inflection point. Okay, so if I said subtract 4, see if I said take x cubed and subtract 4, you see I'm just moving the inflection point down 4.
So is the a bracket plus b bracket cubed plus or minus c, is that your inflection point, not turning point?
Yes.
But it's the same concept.
Yes.
Alright, so when it's inverted, what's the difference in shape?
Good. That's a good question. So if I put it back to 0, and let's look at inverted. So remember, inverted occurs when you have a negative value. I'm just trying to get back to 0. I can't type. Come on. Okay, there we go. You know what? I'm going to change that to increments of 1 so it makes it easier. There you go. That should be easier now. 1, 0. Okay, good. Now A is the number in front of x cubed. Now the value of it will increase, make it thinner or wider, but the direction, so the negative, will invert it. Okay, so if it's negative, it will invert. So you watch, if I drop it down to a negative now, and I keep it to -1, that's exactly the same width, but just a different direction. See how everything becomes negative now? Instead of it being, when it's -2, it's now +8 instead of being -8 like before. So if I type in the second equation so you can compare, let's do x to the power 3. See how they're exactly the same, they're symmetrical. But because one's positive and one's negative, the negative, it just flips. Because all the y values are now, if it was -8, it becomes +8. If it was +8, it becomes -8. So this is your positive graph, this is your negative graph. And you can normally tell if you increase your x values, the more you increase x, the smaller the y gets, the more negative y gets. That's called a decreasing function. Okay? Whereas this one, as you increase x, y increases, we call that an increasing function. So it's positive, negative. Cool? So now I can move that around. I can say if I increase a, so I said if I increase a, you can see it gets thinner and thinner and thinner compared to the original x cubed graph. And all I've done is I made it 10x cubed now. So it makes everything thinner. If I want to make it wider than the orange graph, then it's in between 0 and 1, so it's a fraction. So it's like halving. If I half every term, it gets a bit wider. It takes longer to grow. So if I change it to like a half, so watch, if I get to 1, wait, 1, it stays the same. But as soon as I go into the half zone, so if I go into 0.8, 0.6, see how it's getting wider? It's getting a bit wider. Okay, so the more of a fraction it is.
So if we put like 0.4423.
Yeah, so I can do that. So let's try, if I did a function, let's do h of x equals to 0.4423, yeah, times x to the power 3. You see,
Not very wide, but we put like 0.933.
where's my h?
It's there.
Okay, I'm just going to change that to 0.9 would make it thinner. So it'll be closer to the orange. If you want it wider, it has to be very small. Yep. If we did 0.132, it should be a bit further out from the green. So let's try that. If I did 0.132, see how it's wider? Because the smaller the number, the wider. But as soon as you hit a negative number, so if I change that to a negative number, so if I just put negative, it's the same width, it's just the other direction. Okay, it's still wide. What's that? So that's why the value of A dictates whether it's thin or wide, but the direction indicates whether you invert it or not. Easy? Okay, now I also said if you move it left or right, so I just put this back to 1. There we go. Take these off. Okay, now what you can see is if I make it -2, -10, you see it's not left by 10. That's why I tell you to make it equal to 0. If you solve for x, yeah, if you solve for x right now, x minus 10 equals 0, x equals positive 10. Positive 10 means you move to the right by 10. So the inflection point, which is 0, 0, becomes 10, 0. Okay? Yeah.
Well, with 2.1, it's kind of, you never get something like that unless you kind of complete the square. Is there something like completing the square again?
Oh, for a cubic?
So you wouldn't?
No. Not that we have right now, no. So they only ought to give you that. Well, that's it. So it's limited in terms of techniques, you're right. It's limited that we only got trial and error factor theorem, and then we cubic divide, and we'll get our 3 brackets. That's the only thing we can do at this point. We haven't got any other extra skill except for quadratics. Quadratics was the most sort of in-depth in terms of formulas.
Or are we going to learn the extras?
You're going to learn the extra stuff, yeah. Just graphing. You pretty much got the basics now. 6A to 6D were your basic skills. Now we're just putting it all together to sketch. Okay? So, let's have a quick example. Let's just see if you understand what I'm trying to say. So, don't worry about these just yet. Let's have a look at each and every one of these. So this is exercise 6E. If you can read it now, I want you to quickly read and quickly roughly sketch. Okay? So let's have a look. Let's do the first one. A. Y equals to x plus 2 cubed minus 1. If you tell me what you can read, what is it? What is it doing? What's the plus 2? What's the minus 1? Tell me. Name me one. What are they doing? What's the minus 1 do? Down 1. And what's the x plus 2 do? Left 2. So if you were to draw your graph, your inflection point, which should have been at 0, 0, has now moved down 1 and then to the left 2. So this is your new inflection point. Now, is this a positive graph or is it inverted? Positive, because it's a positive 1 value here. So therefore, the shape will look like that. Okay, and now in order to find out your x-intercept, y-intercept, it's the same drill. Let x equal to 0 to find out your y-intercept. Let y equal to 0 to find your y-intercept. Okay, so if I let x equal 0, I'm going to find my y-intercept. We can do that now. Y equals to 0 plus 2 cubed minus 1. 2 cubed makes it 8. 8 minus 1, 7. So I know that must be 7. The only thing I'm missing now is my x-intercept. To find the x-intercept, you let y equal to 0, because you know the y coordinates are always 0, so we do that. 0 equals to x plus 2 cubed minus 1. Add 1 on both sides. 1 equals to x plus 2 cubed. To remove the cube, what would you do? Cube root. What's cube root of 1? 1, because 1 times 1 times 1 is 1. So This is now x plus 2, and that gives you x plus 2. Therefore, x must equal to negative 2 plus 1, negative 1. So what does that tell me? It just tells me that. And voila, you've sketched a 3-mark question on how to sketch a cubic. Okay, so why is it so important to be able to factorize? Because once you can factorize, you get into these forms. Okay, you can factorize it. If you have 3 of the same brackets, it becomes a turning point form or inflection point form. Okay, so this is 6E. 6F, which we won't get into this session, but you see that's your goal. Your goal is to break it into 3 brackets. For all these, you want to break into 3 brackets because they tell you where the x-intercepts are. See, for me, when I look at it, like for the first one, B, I can say x-intercept is at 1, negative 1, negative 2. So therefore I would write, okay, so negative 1, negative 2, 1, and I'll look at this and say, is this a positive graph or is it a negative graph? And I can see it's x times x times x is a positive x cubed. So the only way to draw a positive graph where as x increases, y increases, that's my graph. Find out your y-intercept. You already got your x-intercepts. You don't need to find a turning point at this point. Okay, in this chapter, you haven't learnt an extra skill to be able to find the turning points yet. That's towards the end in term 4. But at this point, that's what you're doing. See, your goal for every one of these questions in question 2 is to be able to break that into 3 brackets because it's easy to sketch. Okay, and that's your goal. Okay, so the hardest thing is always to factorize. For quadratics, you spend 2 years trying to learn how to factorize. Cubics depends on you being able to factorize. If you can't, you stop here. See, it's easy to tell me what my y-intercept is, which is 6, but finding your x-intercept is the hardest. And that's why you're drilling it. You're trying to learn the factorizing to be able to break that apart. Okay? But anyways, we're going to do that next session, but we're going to work on 6E for this session. Okay, so work on 6E, question 1 and 2. Break this apart. I want you to read them, draw them, find your x-intercept, y-intercept. Okay? I'll leave that there so you can have a look. I should stop the video. Where's the video?